today we're going to look at comparing parallel and perpendicular lines with multiple types of equations. So just to review here on the front, we're going to graph. So on this first equation, my m is 2 or 2 over 1, and my b is a 1. Start at the y-intercept, count rise over 1. Draw your line, because as far as we know, this is continuous. I'm going to use a different color for the second one. My m on the second one is also 2 over 1, and my b is now -4. So starting at -4, rise 2, run 1, rise 2, run 1. And we can see that, in fact, these lines are parallel. So the rule is lines are parallel, or equations even, are parallel when the slopes are identical, or the same. We can write the same, that's fine. In like manner, we can then go through and we can look at perpendicular lines. So when I graph this first one, my slope is 1/3 and my b is -2. So I'm starting down here, rise 1, run 3. I can draw my line. Use a different color here. My slope is now -3 over 1 and my b is a +2. So +2, now I'm going to go down 3 and over 1. Down 3 and over 1. So when I draw this line, I can see, if I use the corner of my ruler, which is 90 degrees, that these do intersect at a 90-degree angle, so they are in effect perpendicular. So the rule for this is that the equations for the lines are perpendicular when the slopes are opposite signs and reciprocal. Remember, it has to be both. Remember, that's the flip. So right here, this was a positive, this was a negative, sign change. The reciprocal of 1/3 is 3 over 1. So how can we take that and go ahead and identify some of these? So here, we're only looking at the slope. The slopes, this is a reciprocal, but it is not an opposite reciprocal. This is a reciprocal, same sign. So this is going to be neither. It is not parallel or perpendicular. Now, these are standard form. You're going to have to change these to slope-intercept. So I can add 8x over here and divide by 2. So I get y equals 8 over 2 is 4x plus, we can leave that 19 over 2 because the y-intercept doesn't technically matter. I can minus 4x over here. Now I have a -1, so I'm going to multiply by a -1 on everything. I get y equals, negative times a negative is a positive 4x, negative times a positive is a negative. And now I can look at my slopes and I can say that in fact these are parallel. On number 3, still some more practice as far as changing. I'm going to add my 2x to both sides. And I'm going to divide everything by 4, so I get y equals 2 over 4 is 1/2 x plus 3/4. Here I'm going to minus 6x from both sides and divide by 3. -6 over 3 is a -2. And then we have 7 over 3. So here I'm looking, it is a reciprocal. And it is opposite signs, so this is perpendicular. Here, it's already in y equals. These are the same, so these are parallel. You're going to also have to be able to manipulate using slope or point slope. So here I have a point I want to know parallel. So that means that I'm going to have a slope of -3. So we're going to write y minus a -4 because this is my y1 is equal to -3x minus 1 becomes a positive. So I can move my 4 over. I can distribute positive times, or negative times a negative is a positive. So I'm going to minus 4 from both sides. Y equals -3x minus 1. That is going to be parallel. And at any point, you can go through and you can use your calculator. So if I wanted to, I could say I could graph my original. So I'm going to hit delete and number 6. And I'm going to put in y plus 4 is equal to -3 parentheses x minus 1. I'm going to hit tab and I can put in y equals -3x minus 1. Okay. It is parallel because it happens to be the same. Oh, I'm sorry. I needed to put in my original. I apologize. So y equals -3x plus 5. But I can see because this overlapped that I did transform this one correctly. So they are parallel. Write an equation that is parallel. Again, same slope to the line below and passes through this point. Well, I need to figure out my slope here. Rise 1, run 2. So my slope is 1/2. So now I'm going to start at 4, 6. Here's 4, 1, 2, 3, 4, 5, 6. And I need to count that same slope. Rise 1, run 2, or down 1, and back 2. Okay. So we're going to write the equation. Y equals, if I do this, down 1 and back 2, I can go to my y-intercept, 1/2 x plus 4. When I look at perpendicular, the slope formula is y2 minus y1 over x2 minus x1. Remember, this is on your formula chart. So again, all we're doing is figuring out if these have the same slope. So I can say for M and A, this is weird how they've done this, X and Y. So the M point is 3 and 6, A is 4 and 8. And then I need to come over here, T and H, how clever spells math. -4, -7. So we're finding the slope here, plus 2, plus 1. So my slope is 2 over 1. Remember, it is y over x. Here, minus 12, minus 3. -12 over -3 is a positive 4 over 1. These are not reciprocal. They are not even the same. They're the same sign, but they're not the same. So this is neither. Here you can use your point slope formula. We can say 2 minus 10, right? Because that is y2 minus y1 over x2, -5 minus 9. So for those of you who like the formula, -8 over -14 is, that simplifies by 2, so positive 4 over 7. Here we can do 2 minus a -2 becomes a positive. -1 minus a -8 is a positive. 4 over, this becomes 7. Negative, this was a negative and a negative, so it became positive. So these are the same, so this is going to be parallel. And here you can use whichever formula you want. I'm going to go ahead, I'm going to stick with points. I'm going to do y1 minus y2 over x1 minus x2. So I have 13 over 0. Uh-oh. Let's see what happens here. -2 minus 6 over 11 minus 11. So -8 over 0. These are both going to be undefined. So this is also going to be parallel. All right. Write an equation that passes, okay, perpendicular. So if my slope is 2 or 2 over 1, my perpendicular slope is a negative 1/2. So I'm going to say y minus 1 equals negative 1/2 x plus 2. I'm going to distribute. Negative times a positive is a negative. Negative 2 over 2 is a negative 1. So we just get y equals negative 1/2 x. You could put the plus 0, but it's not necessary. And again, I would go ahead and graph this to make sure. If you hit delete 3 times, there you go. And I'm going to put in this first one, y equals 2x plus 7. I'm going to put in my second one, y equals negative 1/2 x. There they are perpendicular. If I wanted to make sure that I converted this, I could also say y minus 1 is equal to negative 1/2 parentheses x plus 2. And I can see I did convert that one correctly. Write an equation that is perpendicular to the line below. So again, find the slope, 1, 2, 3. 1, 2, 3, 4. So my slope was 3/4. So my perpendicular slope is a negative 4/3. So I'm going to go to negative 8/3 is not on the graph. So we can't use the strategy we used before unless we just want to extend it. Negative 8, 1, 2, 3. My slope, we can move this and say 4 over negative 3, same thing. So I can go 1, 2, 3, 4. Oh, that's not going to work because we need it to go down. So we're going to have to go back to the way we did here. Y minus 3 is equal to a negative 4/3 x plus 8. Distribute. Negative times a positive is a negative. This is 32 over 3. And then we're going to add 3 to it. And again, work smarter, not harder. I can definitely put that into my calculator. Negative 32 over 3 plus 3 is a negative 23 over 3, which is ugly. So y equals negative 4 over 3x minus 7 2/3. So I would like you to attempt the back. I will post the answers on the Google Classroom where I post the pictures of these notes. But I would like you to try it and check yourself. And then there is an assignment afterwards.